Yeah, go through your normal way, however you signed it up. However you set it up is.
Yeah, I just have to do that.
Sorry.
No, it's not bad.
That's very much. Mhm.
Let's try to access this. Sure, the sign is not working.
Yeah, go ahead.
I'll just do this. I can put like do through this way. I've never done
Yep,
that.
try the DUQ. But you won't have, you can't be host that way if you didn't do it originally.
He can log in from his phone and then make like this account
Okay.
host.
Oh, you can see there also, I must say.
Can I do it through my Gmail, do you think?
You have sent the, you can just join through Zoom, the ID number of the meeting, you just won't be host, but I think that should be okay, because Paula's probably on there already.
Yeah, she's on there now. I got an email,
Okay.
notification from my Gmail.
Mm.
So I can probably go through.
You can go,
Sorry about that.
no worries, this is not something that you do every day, right, like the rest of us. Okay, so if you don't mind, I mean, you could try that, but I think also there should be a Zoom in here, where if you signed on as your, yeah, so this is already signed on as you, so you can just join a meeting.
Yeah. If you put
So-
meetings is where I am.
Oh, okay, so it was through your, no, it shouldn't be in here, because you did it
Just,
through
This is
Gmail.
okay, I did
But
it.
just join a meeting.
Up there,
How do you do that? Where is it? Up there, join. Okay, alright, you type in the ID number. Or if somebody who dictates Delia the ID number, that would be great.
I just. Sorry about the technical difficulties.
That's all good.
I should have done it through.
So it's 844.
844-7639.
You said 8W?
844-7639-7573.
It's not typing anything in.
Oh, are you listening?
Because.
Here.
Yeah, no, I'm just,
Oh,
I
okay.
just can't understand.
844?
Thanks.
Yeah, that doesn't work over there, you have to use this one, right?
76.
7639, and then 7573. And then
That's good.
just what we need, a passcode.
Yeah, there's a passcode.
This is very helpful.
Yeah, of course I put a passcode.
We'll remember this one, Stelio, thanks.
Sorry guys, I'm wasting you guys.
Never expected this one.
Alright. Awesome.
So now log
Now
in
you have to
to
log
your
in.
Gmail from your phone and start the meeting.
Yeah.
Oh, yeah.
Yeah, right.
Yet to open
Right,
that.
yeah. Asset knows all of that, secrets.
I should have done it for my phone.
This is part of your grade stuff.
Yeah, I know. I figured I already could. Yeah, I'm just starting like that.
Flashback to the pandemic days.
It's no longer
right?
Zoom, it's Zoom.
That's right.
I'm starting to hate Zoom.
Just got hit ENS alert. So
I'm gonna admit Dr. Leonard.
Right.
Can you click both sides?
And I'm gonna admit me too right now.
Here we go.
Mm.
And then make yourself co-host.
All right. Wait for the echo, everyone.
There it
Yep.
Here we are, Doctor.
Mute your phone. There we go. Now everything's good.
Or you can like
Make sure I'm not mute. Okay.
It's okay.
You can hear me, Dr. Leonard?
Yeah, she said.
Yes, but I don't see anything.
Okay.
so just share this.
Oh yeah, just go.
Just share the screen.
I'll just share it.
Just to share the screen.
Yeah, click
And
share.
then click on the right-hand side,
On share.
Oh,
Right.
got it.
Yep, yep.
Doing a PowerPoint.
Yes. I mean, yeah, you know, normally we set up like before, but there was a classic
Yes,
here, so
yes.
sorry everyone, or me too.
Yep.
Okay, so thank you all for coming.
Yeah, thanks for coming. Doctor, look, what I could do is open it from my email that I sent to everyone.
Yeah. I can see everything you're doing right now. I don't know if you can share your computer screen.
Yeah, can you see the computer screen?
Yeah.
Okay. I'm just opening it.
You can
Yeah,
just.
we're still getting the PowerPoint situated, so.
Got it, okay. No
Yeah,
worries.
sorry again about that.
That one.
Okay, I can see everything, thanks. Okay, I can see.
Slide
So
show.
I'm gonna have you go, there we go, and then you hit, I'm sorry, let me step on your toes, right there, that
Yes.
button. Right there, yeah. It should work, but it's not. Okay,
Let's see slideshow.
I think it was not open in PowerPoint, like the PowerPoint was on the.
yeah, I think it's online.
Just
It's online.
download, you can download the PowerPoint on the
Yeah,
desktop.
I agree with that.
Just go to the Outlook tab.
Those are shared, let's try to get this thing. Yes. Outlook,
Just click download.
Asif is the unpaid,
Yeah, this is downloading. The first one was
the
done.
unpaid tech support. Opening in protected view. Processing. Okay, so.
Just click enable editing.
Yes.
That should work.
Yes, yes.
There we go. And I think you would hit that. There we go. Yay!
Okay.
Alright, well, it's only gonna be uphill from here, so. Well, I promise, guys, that was,
All right.
it's okay. Sorry for waiting. Thanks for being patient. Just wanna start by saying thank you to everyone that's been able to be here. I'm excited to get this presentation today. There's some great teachers that have given me some great presentations over my few years here. So, let's get started. Analyzing the efficacy of resveratrol-loaded nanoemulsions against triple-negative breast cancer cells. I also think it's fitting that I get to give this presentation during National Breast Cancer Month. And I just made the cut too because it's like October 30th, so got a couple days before November, so it's ideal timing. So I appreciate Dr. Lee with that. Ends up being nice. So a little bit about triple negative breast cancer. You'll take note that it's the most invasive and metastatic subtype. There's a few reasons for that I'd like to get into. When looking at triple negative breast cancer, there are three main things to look at are the three receptors at play. The two hormone receptors such as estrogen receptor and progesterone receptor, as well as the HER2/neu receptor. Now, when looking at the hormone receptors, a lot of times you'll hear about endocrine therapy that's used for them. So there's tamoxifen and other aromatase inhibitors such as anastrozole and letrozole. Those are used, of course, if those receptors are expressed in the particular patient. For the HER2/neu receptor, if that were to be positive in a patient, there's an agent called trastuzumab, also known as, goes by the brand name Herceptin. And so in that situation, it could be used for patients that have an overexpression of the HER2/neu receptor. Where it gets tricky with triple negative breast cancer is when all three receptors are not expressed in the patient, thus making it much harder for targeted therapy. Oftentimes that's going to lead to chemotherapy being the mainstay and the best treatment option. And something that I'll get to a little bit later down the presentation is how can we ideally lower that chemo dose and help the patient that way. And a little bit about the epidemiology of it. Among the breast cancers, around 10 to 20% of diagnosed patients, more so like 15%, are triple negative. When looking at the field of cancer, there is a lot of drugs being researched right now, particularly natural compounds. One of those being resveratrol, and that's something that we're going to take a look at here, what we've been doing with research. So this natural compound is a natural polyphenol that's found in a variety of foods that you guys, I'm sure, are associated with eating, such as red grapes, things such as dark chocolate, blueberries, and peanuts. It's also interesting because resveratrol has been proven before to have antioxidant powerful benefits. So there is research out there to show its benefit in cardioprotective effects, cardiovascular disease, that is, diabetes, and other diseases like that. Here I have the structure of resveratrol and a couple more foods and sources that you can find it in, such as strawberries, red wine, peanuts, and mulberry. A little bit about resveratrol and breast cancer. Resveratrol enhances the death of triple negative breast cancer cells, which is something very cool that we've been learning in our lab through different research articles. And these articles have also showed us that TNBC cell proliferation was inhibited when treated with resveratrol. Something that was very interesting for me this summer was when I was reading about resveratrol and the extent of its effects on cancer was proven. And then when you read a little bit more and find out that it has some triple negative breast cancer effects, I believe that was even more of a inclination to research it further. A bit of a problem identified with resveratrol would be its poor bioavailability and its chemical instability. Another way to go about this would be saying that it has a poor pharmacokinetic profile. So that is a bit of a problem that we were able to identify when researching this. However, we believe that a potential solution for this would be when we encounter and incorporate nanoemulsions for drug delivery. I'll give a little bit of an intro about nanoemulsions and what they are about, kind of, because I'm not sure. It's kind of a common term you hear out there, but really, what is nanomedicine? It's a category of medicine associated with nanotechnology, and then more specifically, the manufacturing of materials on a very small scale size, 1 to 100 nanometers. And specifically for this project, I've been looking at an article with Dr. C and Dr. J, Dr. Yanich, from a few years ago, and they described nanoemulsions as kinetically stabilized emulsions with low surfactant concentration. And another point they make are how they talk about the high energy approaches that are used to make this. And as I mentioned, we believe that this is a potential solution and can solve for the poor pharmacokinetics of resveratrol and low bioavailability exhibited by free resveratrol. A little bit about the nanoemulsions themselves. They were formulated and produced in Dr. Yanich's lab, which we really appreciate their help with that, specifically Amit Das and Elise. Also, Sherlock from Yanich's lab helped with the cell toxicity protocol. Now, when I spectated him and observed him doing that about a month ago, that pretty much incorporated the raw macrophage 264.7 cell line. So essentially what we're doing there was ensuring that these nanoemulsions were going to ensure the cell viability of the macrophages before we brought them over into Kavanaugh lab and examined the effects there. A lot of drugs in the field of oncology today work by this PD-1, PD-L1 activity, specifically different mechanisms of the way they are expressed. So I was going to do a quick overview on that before I get into some of the drugs that work that way today and the potential role that resveratrol may play here. So PD-1 is the protein on the T cell surface, and PD-L1 is the protein ideally ought to be on the cancer cell, which is what used to be an immune system that was then hijacked. PD-1 stands for programmed cell death protein 1, and programmed cell death ligand protein 1 is our PD-L1. Now, when PD-1 interacts with PD-L1, what that essentially leads to is the immune system being put in check, so to speak. That essentially means that the cancer cell is binding to the T cell in a way that is not letting the T cell kill the adjacent cancer cell, because another way you'll hear this said is that the brake is put on with this interaction. A few main drugs that work modulating the PD-1, PD-L1 activity, I'm sure you guys have heard of, are Opdivo and Keytruda. These are both anti-PD-1 antibodies. Specifically, you have pembrolizumab and nivolumab. Now, it's a little bit different, and the only main difference between these two drugs are how they're formulated, as you have fully human monoclonal antibody in Opdivo, so that can translate to less common hypersensitivity reactions in that case. However, these are both common drugs that are very well known right now. They're treating a variety of disease states, but they particularly have a good role right now with triple negative breast cancer. I know Keytruda does in that regard. And these drugs prevent the interaction of PD-1, PD-L1, thus allowing the T cell and the immune system as a whole to do an effect and produce an anti-cancer, anti-tumor effect. As I mentioned, immunotherapy is a rapidly emerging area for cancer treatment using these two drugs, and these are only two examples right now, but where it got interesting for me was during the summer, reading about resveratrol and its potential mechanisms of use, and coming across some articles speaking about its PD-1, PD-L1 activity. And I thought that was very interesting because of the blockbuster drugs such as Opdivo and Keytruda that have anti-PD-1 activity. So I thought that'd be a great avenue to go down for research. A little bit about resveratrol and ERK signaling. Kavanaugh Lab is very familiar with ERK5, the MEK5, ERK5 signaling pathways, and they have previously demonstrated how inhibiting ERK5 signaling therefore leads to a reduction in TNBC cell proliferation. As a whole, it's very commonly researched because of the good outcomes that we've seen from researching it. In our lab specifically, we're getting familiar with the cell line MDA-MB231. And that's been used for quite some time here in the past few years that I can recall with Kavanaugh's lab and Dr. Kavanaugh's lab, and analyzed via Western blots. And I included this unique picture. I put another one later down in the slideshow from a Cheetah bot from Dr. Kavanaugh's lab back in 2021, which is showing the cells treated with DMSO and other So the overall hypothesis is something I'll just plainly state, so I can just read it. Resveratrol-loaded nanoemulsions will decrease triple-negative breast cancer cell viability and proliferation through inhibition of PD-1, PD-L1 interaction and/or HER5 signaling. Within this research project, we undertook about 2 project aims, which I'll get into in just a little bit. Brief overview of them. For aim 1 is determining the effect of resveratrol on triple-negative breast cancer cell survival. This is done by treating the resveratrol-loaded nanoemulsions and analyzing the cell survival via cell titer glow assays, which I'll get into more in just a second. Before, I'm just going to mention aim 2 before we get into it later, which is examining the effect of resveratrol on cell signaling cascades, mainly through Western blot analysis that will later be used to determine, like I mentioned, the PD-1, PD-L1, and ERK activity. After treatment with the vehicle-controlled resveratrol and drug-free nanoemulsions. So a few more specifics about aim 1. We plan to determine the effect of resveratrol on triple-negative breast cancer cell survival using cell line, triple-negative breast cancer cell line, MDA, MB231. Now I mentioned it's a little bit more of an aggressive cell line, and ultimately the lab, Dr. Kavanaugh's lab, is familiar with this compound, so we believe that there can be better results in that manner going this route. aim 1 hypothesis is triple-negative breast cancer cell survival is decreased following treatment with resveratrol-loaded nanoemulsions. Another small point is that we use cell line MDA MB231 for this project. However, Dr. Kavanaugh's lab is familiar with a few other cell lines with different genetic profiles that we hope to get into sometime down the line. Now, determination of cell survival following treatment with the resveratrol-loaded nanoemulsions. Something that we used throughout this experiment was cell titer glow, essentially a way to analyze our cell tox data and interpret results later down the line. A basic structure for this experiment as of now, I divided into a week 1 and week 2 with a small difference between the two. In week 1, we had the resveratrol-loaded nanoemulsions and the drug-free nanoemulsions, and these both were tested against triple-negative breast cancer cells. So on day 1, we seeded the cells in a 96 well plate. We waited about 24 hours, and then I come the following day, and we then treated the triple-negative breast cancer cells with both the resveratrol-loaded nanoemulsion as well as the drug-free nanoemulsion. Day 3 included the actual cell toxicity and analyzing the data from Dr. Mandenkamp's lab, using the machinery there. And then the small difference in the following week, we were able to repeat the experiment, which gave us a little bit better experience and being comfortable with the experiment. However, we incorporated free resveratrol, the free drug resveratrol, in to get some more data from doing that also. So I'll get to the data in a second right here. As we can see that drug-free, that is resveratrol-free nanoemulsions, decreased triple-negative breast cancer cell viability. Now there's a lot of numbers here, but I could, to break this down a little bit more simply, if you look at columns 7 through 11, there are they're higher numbers, so that there are more cells still alive showing there. So oddly enough, the resveratrol-loaded nanoemulsions were treated with the right side. And on the left side here with the lighter shades and less cells was the drug-free nanoemulsions. So this essentially means that from our data produced that more cells were killed with the drug-free nanoemulsions, which did have us scratching our heads and postulating as to why that could be. And I'll get into that in a little bit. However, looking at week 2, putting the experiment again, we've noticed similar results where it seems that the drug-free nanoemulsions killed more cells than the resveratrol-loaded drugs. As you can see, less cells in that area from columns 2 to 6. A little bit difference in this one from week 1 would be the rows E, F, and G. That is the incorporation of the free drug resveratrol. Something important to note about the free drug resveratrol incorporation would be that there could have been a miscalculation and a few other things that could have gone not according to plan, which is why some of the data from that will be conducted again in another experiment. However, we only have 1 week of data from adding the free drug resveratrol. Concluding AIM-1 and looking forward, we've mentioned that drug-free nanoemulsions decrease TNBC cell viability to a greater extent than looking at the resveratrol-loaded nanoemulsions. So going forward, we plan to meet on various occasions with Dr. Yanich's lab and talk about these findings, which we've done a little bit right now already. Dr. Yanich seems to believe that, based on what they've done, they have treated these nanoemulsions and they have proven that there is no inherent toxicity with these nanoemulsions. And so they kind of believe that maybe this data shouldn't have came out this way, or maybe it just, at this point, kind of just puzzles us. In reality, when looking at it, there could have been a procedural error. It could have been something as simple as switching a vial or something with the calculations. But to go about this, we plan to repeat these experiments, and we're also looking into the possibility of, when meeting with Dr. J's lab, to have a member from their lab perhaps come in and do the cell tox. A few reasons for that would be their familiarity with nanoemulsions. Lulu, otherwise known as Sherlock, is very experienced with nanoemulsions and doing the cell toxicity protocol. So we're possibly considering having him come in and doing that portion, or even doing more of the experimenting ourselves. But when you look at the data, there's 2 similar sets of showing the similar thing in terms of drug-free nanoemulsions seeming to have a toxicity and killing more cells. When talking about AIM-2, it's important to know that this is a little bit more of a long-term goal, because this is something that hasn't really come to fruition yet, but it's just something that we are planning to take over soon. That is examining the effect of resveratrol on cell signaling cascades. So I'll go ahead and read the hypothesis here. This hypothesis has a couple of sub-hypotheses underneath it for a little bit more specificity. The hypothesis for AIM-2 goes as resveratrol-loaded nanoemulsions will inhibit cell signaling. Will inhibit cell signaling that promotes TNBC cell survival. To further describe this, sub-hypothesis 1, resveratrol-loaded nanoemulsions will inhibit the interaction of PD-1 on the T cell and PD-L1 on the cancer cell. Our second sub-hypothesis is that resveratrol-loaded nanoemulsions will inhibit ERK5 activity in triple-negative breast cancer cells. Again, we plan to use Western blot and analysis of these effects on the cell signaling cascades as we progress. I'm sure a lot of you are familiar with what a Western blot analysis is, but I am going to give a little bit of a background of it. It's essentially a laboratory technique that's used for detecting proteins in various tissue samples. And the expression of these proteins is interesting because it can be somewhat semi-quantified. I have here another figure, as I mentioned before, from Ekshita Bhatt from 2021 of her Western blot using the cell line MDA MB231, which I thought was interesting to include as kind of gives a background and a visual as to what a Western blot analysis or what a Western blot looks like. Something down the line that we may follow up after a Western blot would be transfer assay utilization, and where we may look to transfer proteins from a gel to a solid membrane. So in conclusion, and to summarize some things, it's important to call back to one of the earlier slides in looking at treatments of triple negative breast cancer and how there are no targeted treatments, again, because of the lack of expression of the two hormone receptors, progesterone and estrogen, as well as the HER2/neu negative expression. Now, what we found is, and what a lot of researchers have found, is that natural compounds like resveratrol, they may be used to target triple negative breast cancer with reduced collateral toxicity. Looking more long term, it'd be interesting as a monotherapy in some certain patients. However, I believe that a more realistic approach and goal would be combination with chemotherapy. So ideally reducing a chemotherapy dose. So a lot of chemotherapy right now gives you your hallmark side effects such as nausea, vomiting. A lot of agents give you diarrhea, hair loss is very common. And a lot of those side effects are very hard for patients to go through. So I believe that if through using resveratrol-loaded nanoemulsions down the line can ideally lead to a lower dose of chemo needed, I believe that the patient's quality of life can be severely better in that sense. Now, I mentioned the anti-PD-1 antibodies earlier. I believe that that's a promising field of immunotherapy and where cancer research is going. However, I believe that those agents also have shown their respective side effects, such as colitis, pneumonitis, and thyroiditis. So you hear the itis a lot because of their hypersensitivity reactions that those drugs give. However, I believe that with our resveratrol-loaded nanoemulsions, I believe down the line that there is a little bit better side effect profile while also yielding a degree of therapeutic efficacy. And at the end of the day, through my research and through my schooling of pharmacy, it comes down to the main goal of improving the quality of life for all patients, and specifically with our research, triple negative breast cancer patients. And I have to acknowledge Dr. Kavanaugh for being my advisor and a lot of help throughout this process, as well as Dr. Jay's lab and Amit Dawson and Elise Choidal for making our resveratrol-loaded nanoemulsions, as well as Asif. I appreciate him for being patient with me and teaching me how to pipette and cell culture and learn so many great things in that lab. And I look forward to the continued research there. And then I appreciate Sherlock and Rebecca. Rebecca's been the lab manager, coordinating a lot of meetings for us where we could get together and plan meeting times for our research. And Sherlock, again, as I mentioned, he may play a factor later down the road in more cell talks with the triple negative breast cancer cells, but as I mentioned with his raw macrophage line, I really appreciated his help in hitting the ground running with that. Any questions?
I think there's a chat question, if you wanna just go into the chat and see what Dr. Benedetti said.
Rahan, I'm having trouble hearing you.
Oh, okay, I was just telling him to go to the chat.
Okay, I have them in the chat and I could read them. Do you want me to read some?
It's
Oh,
okay,
I
we're
can read
looking at it now.
Okay.
I got it.
Just go one by one.
One by one? Okay. Addressing Opdivo and Keytruda as positive controls, we did not. I believe the limitation with these with respect to the resveratrol nanoemulsions is a far different amount of data. I mean, I believe that there's a lot of studies for Opdivo, particularly, I mean, it goes even further than breast cancer for Opdivo and Keytruda. There are second line approved settings for Opdivo in lung cancer. Pembrolizumab is used in lung cancer extensively, specifically non-small cell lung cancer, as well as Opdivo. I believe that there's just a lot more data with those agents, and we're seeing way better outcome on patients with these. And as
Can I answer something, or ask
Oh,
something
yeah.
with that?
Yeah.
So where I was kind of going with those, first of all, I love that you brought in, realistic drugs, but these are monoclonal antibodies, as you said, right?
yes, yeah,
So they're gonna work very differently as something as a nanoemulsion, which is, very novel. And so one thing you always wanna consider when you're running controls, you have to run a control to just show that your target is being specifically, inhibited and you're showing that effect. And you wanna show similar actions, but you always have to keep in mind the type of drug. One is a monoclonal antibody, which will act very differently than a nanoemulsion. So it's just something that it's just, every model has inherent weaknesses and limitations. You just have to point those out and kind of bake them into the interpretation of your data. Very nice bringing those in.
okay, thank you. And I noticed you mentioned MDA, MB231 cells. And
Yes.
whether, okay, yeah.
Yeah, do they express PD-1 and PD-L1? I mean, do you know that if they even express those to see an effect?
As far as I know, they don't. I just know that triple negative breast cancer cells do, and obviously, and I know that's vague, so that's something to look into. I'll have to look into that cell line specifically, and we'll do that as a group. But though that cell line together, I would not be able to say if they do or not, besides just TNBC cells as a whole. But the specifics of this one, I could not say.
Yeah, and whenever you're working with natural products, I still run, like we saw an unexpected result with our tamoxifen melatonin drug conjugates. We just ran triple negative cells and didn't think we were gonna see a response, but we actually did. And it opened up new mechanisms of how tamoxifen works independent of estrogen receptors. So I would still run these, but maybe it won't be through these proteins. It's just something to rule in or rule out mechanistically.
Okay, thank
To
you.
think about.
Okay, thank you. Well, definitely that's something we'll look into, and I'll get back to you on that as well as we further analyze it.
While we're still on that question, though, I'd like you to kind of step back a little bit and think about the PD-1, PD-L1 interaction. PD-1 you had mentioned is on the T cell, which is not present in your cultures, and the PD-L1 is on the cancer cell, which is present in your cultures. So maybe your cancer cells do have PD-L1, but then the monoclonal antibody binds PD-1 and not PD-L1, so that would not work as a positive control. You'd have to find something against PD-L1 to see that the PD-1 is not aberrantly expressed by the cancer cells, which do all kinds of weird things, right? So, what you're hypothesizing, I think, is that the resveratrol prevents the activation of the PD-L1
Yeah, I believe that's it.
receptor, and the downstream signal transduction cascades, is that known to be linked to MAP kinases like ERK5? It might be, I don't know.
Ideally, we're gonna look at it, to what degree is it all linked together. And I know I mentioned in my sub-hypotheses ERK5 being separate from PD-1 and PD-L1, but like you mentioned, the downstream signaling cascade is the.
They all connect.
Right, yeah, they all.
Yeah, eventually they all connect.
Right.
Somewhere they will talk to each other. So, but resveratrol is also an antioxidant substance.
It is, yeah.
And so it might prevent damage to DNA, because the biggest DNA damaging agent is reactive oxygen species. And that should also prevent cancerous transformation, right? And one alternative hypothesis to keep in mind that may be a little bit unpopular is that resveratrol, through its antioxidant effects and other protective effects, prevents the toxicity of the nanoemulsions.
All right.
At least in twice you've seen it, right?
Yes.
That's not likely that you've mixed up the labels twice in a row, right? So that's just maybe one thing that would be interesting to try to understand.
Yeah, we'll definitely look at that. Something interesting we saw or thought about more so was, while these drug-free nanoemulsions may not have shown toxicity in previous labs, against the macrophages, there could be something unique about MDA, MD231 that would give a rare toxicity, that would maybe something, it yields us something that we have not seen before if they haven't been treated with MDA, like 231 before, if that makes any sense. Because while they kept the macrophages alive, it could just be something about the unique nature of our cancer cell lines, but that's something that we'll look into
I have
further.
another question about that, and that is that were those nanoemulsions that were loaded with resveratrol made at the same time, side by side with the nanoemulsions that were used without, that were drug-free nanoemulsions? Because, you know, for all you know, they could have been from different batches, and then, you know, really, everything is toxic at high concentrations. So if the concentration was a little bit off on one compared to the other, that could have led to more toxicity of one group compared to the other if they're not truly made in parallel with the resveratrol added to one and not the other, all side by side.
Right.
If you know what I mean, because then it's sort of internally controlled for dose, right? Because the nanoemulsions are lipid-based, they have lipids in them, and that might lead to some toxicity too if that's fusing with the membrane. You know, I mean, it's just sort of good to be open to alternative interpretations compared to what the expected hypothesis is.
Okay. Thank you.
Rahana, I'm noticing that there's 3 minutes left on the Zoom for me, so.
Yeah, that's what I was worried about would
Oh, sorry.
happen.
It's okay.
You go
It's
for
okay.
it.
So
Go for
I
it,
have just
Paula.
one more question, or you guys, it's gonna
Yeah,
automatically.
you go ahead, you go ahead.
Okay, but it will still kick me out in 3 minutes.
Yeah. Maybe
I don't like this.
Can you just read the last one? I'm just looking at the microplate reader analysis, and if you need help in, making these into graphs and getting IC50 and efficacy values, we'd be happy to help you, because that looks really fun. But can you read that and then answer
Okay.
the question?
We do have graphs, I believe Asif has them in the Google Doc, but there's nothing I included in the presentation. So we're gonna look at I can bring those graphs up later to you also and take a look at those graphs. And so we do have graphs of this data and plan to get more.
Yeah, one thing about graphs besides the quantitative data, because you're looking for IC50 values, because you're looking for kill and inhibition, but you're also looking for efficacy, which is really what you want to demonstrate, right? You want fairly good potency so that these things connect in vivo. So you always want like like around the nanomolar range for IC50 values. And then you have to determine what is considered a good inhibition rate, like sometimes over 50%. Sometimes you don't get that with these things. But more importantly, sometimes it's the shape of the graph, because it gives you some idea of mechanism. So yeah, we'd be happy to, I'd love to look at the graphs and to see what they look like. You know, I'm very interested in natural products, and I think that what you've done, you know, is very novel in terms of natural products, but also nanoemulsions. And I just want to highlight that, 'cause it's very hard to do these kinds of assays. So great job.
Thanks so much, I really appreciate it. Sorry about the Zoom, I thought I couldn't
It's
set it up.
okay,
I've only set it.
I should have made a Zoom for you, I didn't realize we were gonna go to your Gmail and not your.
Yeah.
No worries at all. I didn't want you to think I was being rude.
No, I appreciate the feedback, though. We'll definitely get the graphs out, and I'll definitely reach out about that.
Can you go to the data, the raw data?
Yeah, here's.
So what is what? That, even if you don't have the graphs, you should, in the future, you should label what each column is or what each row is.
Yeah, just walk us through it.
Yeah, can you just, walk us through what's what?
Yeah, I can, yeah. So, I will include that for the future, but essentially it's just, as I mentioned, the drug-loaded nanoemulsions here, drug-free, I'm sorry, and then the drug-loaded.
Yeah, but is it different content?
Right,
What
yeah.
are the different columns?
What are the different,
Yes,
so
yes.
column 2 is what?
Column 2, we use, we did like a twofold serial evolution. Right, awesome. And then,
Of what?
Oh, yeah.
Full.
So
The
column, so,
nanoemulsion or the cells?
the,
Should I?
can you help him?
Okay, so from column 2 to 6, it's drug-free nanoemulsion, and from column 7 to 11, it's drug-loaded nanoemulsion. and from 2 to 6, it's gradual increase in concentration. So starting from 5 microliters per ml of nanoemulsion in both cases, drug-free and drug-loaded. So starts with 5 microliter, the next one is 10 microliter per ml, 20, 40, 80.
Okay, and then why do you have 4 values in columns 2 through 6 and only 3 in columns 7 through 11?
Oh, so the E row, that's just media as a negative control.
E is just media.
I can tell this is a clear plate and not an opaque plate.
Yeah.
It should really be opaque because you're getting scatter of the luminescence. The photons are being picked up from neighboring wells, which is most apparent in column 7 and row E because it has 2 neighboring wells that have light being emitted from them. So you should transfer it into a white plate, not a black plate, because the black absorbs the photons. Black absorbs light, we know that.
Yeah.
But the white plate will really make all that light go to the top of the detector because it reflects light.
Is that what you use for self-taught
Yeah.
glove? Use white plate?
Actually, we used to use the same white plate, one white plate over and over.
Yeah, you
because
just
it
keep
being
washing
washed.
them out, yeah.
Yeah, because they're expensive.
Yeah, that's right, we used to do it one time.
I think, didn't we have I believe that we had a positive control going too when we added the free resveratrol.
Just 1 second as you're looking here though. Go back, yeah, so there's really, it looks like, if you look at the raw numbers, there's like a few outliers in the,
There is.
you know, like the 1,380. I don't know if they're statistically, if we're able to, if they're 2 standard deviations away from the mean, I'm not sure, but that's the rule for throwing away data points, right? So when you, I agree with Dr. Udendry, when you graph these, you might see the same trend in the emulsion-free, or resveratrol-free and the resveratrol-loaded.
No, so in both cases, the cell viability is lower in the drug-free nanoemulsions.
Yes, but that includes those maybe outliers at the top. And then let me just see this a second, like 18. And so what is that's the free resveratrol in E,
Yeah.
F, and G?
At the
Yeah.
EF and G at the bottom.
Yep, I kind of botched that up.
But I believe that the resveratrol is increasing as you go from left to right.
Now, I wouldn't trust the resveratrol data here because
Oh,
when
okay.
I made the solution, there was.
So we shouldn't look at E, F, and G, right?
Yeah, no.
We're just seeing the same things.
You're seeing the same thing twice.
2, 3, 4, 5, 6, rows B, C, D are drug-free nanoemulsion. And then 7, 8, 9, 10, 11 are resveratrol loaded. Okay, this one looks a little tighter. I don't know, in terms of data. So can you go back a second?
These data look good, the cells are healthier, the raw data are higher.
Yes.
They're
Right.
pumping out more ATP because they're healthier.
Okay.
Okay, yeah, it would be helpful to see these in graphs, but you can see that in this case, the drug-free.
There's about a 50% increase in ATP concentration with resveratrol present, which is very interesting, right? So maybe resveratrol helps mitochondria to function better because of its antioxidant.
Yeah, maybe.
Yeah, you're speaking to the dramatic increase.
Yeah, and it's only evident at the higher concentrations of the nanoemulsions because I think it's probably saturated already. Like columns 2 and 7 are very similar because there's probably saturation, which happens very quickly in a 96 well plate over the course of 3 or 4 days.
But
You know,
why
that's,
2 and 7? So that's the
Well, 2 and
that's the
7 are the
lowest.
controls. Yeah.
They're the lowest.
Yeah, so if resveratrol by itself, because 7 through 11 is resveratrol, so I assume 7 has
Nanoemulsions.
resveratrol, right. So 7 has the resveratrol in the nanoemulsions, and 3 has nanoemulsions without resveratrol. Those are the 2 baseline columns.
7 and 2.
7 and 2. Am I right about that?
I think so.
Still? Charlie, am I right about that?
Yeah.
That 7 and 2 can be compared, and 3
Yeah.
and 8 can be compared?
Yes, those have,
Okay,
yeah, because those
good.
haven't been.
Yeah, so,
So
So the
like
difference
if
really-
you compare each of the like drug-free and drug-loaded for each concentration, the trend is kind of similar for all of them. The difference in cell viability is the trend is kind of similar for all of them.
what do you mean all of them?
Yeah.
Like so for each concentration, like so like for 5 microliter per
Oh,
ml.
relative to the control group,
Yeah.
the nanoemulsions decrease viability
Yeah.
to the same degree.
Yeah.
Yeah, that makes sense.
That's something that, and I said we have graphs also that we'll get into later. You know, but
It's nice to see the raw data.
yeah,
Very nice. You just need labels.
that's why we were
That's all.
looking.
Yeah. Mainly labels.
Yeah, right. Sorry. We'll have to look into also whether between repeating kind of an experiment or, you know, like we're gonna meet with Dr. J's lab too to talk about but we've seen this twice, like as we see, so.
Well, just listen to what Dr. J has to say. And also remember that the dose makes the poison from what we talked about.
Yeah.
Hope you remember that.
I said, I think that to myself every day, I think that.
That's good.
You could ask Kyle.
That's
Right.
hilarious. Oh, yeah.
That's like our favorite saying, actually.
That acetylcholine.
Acetylcholine is your.
Acetylcholine, you gotta eat lots of eggs to get good acetylcholine.
Cool.
I have a few more questions, but let's go with some questions at this point.
Yeah, please.
Yeah, I have a quick
Yeah,
question.
please, Scott.
So, if you, when you're saying like PD-1 and PD-L1,
Right.
they're like the natural brake proteins on the immune system, right? So if you're inhibiting that process, is that gonna like overactivate it? You know?
You do see that at times. I believe that's why you have the hypersensitivity reactions, because while you do free up the immune system to do its job in killing the cancer cell, it can lead to overactivity that we do see in many patients when they experience pneumonitis and the itises, so to speak. So that's kind of the hallmark side effect with those agents and the benefits and drawbacks that I believe, have to take into consideration when we use them. Does that make sense by the,
So like resveratrol, would that have like the same effect on?
that's a good question. It's effect on the immune system. I'd like to look into that more.
Well, one of your hypotheses is that resveratrol will inhibit the interaction between PD-1 and PD-L1.
Moderate,
Right,
it's
so
moderate.
I guess the question to think about answering in the future is how would that happen at a biochemical level, right? First of all, in your cultures, there's no PD-1 because the T cells are absent. So it's a downstream signal transduction cascade that you'd expect resveratrol to dampen.
Yes, yeah. It's a good point, like, more so by molecular level.
Has resveratrol been shown to activate ERK1/2 in other models?
So
As
I've
opposed to
read,
inhibit MAP kinases?
there's an article I was looking at last week about its activity in ovarian cancer cells. But I believe it also was inhibiting I forget where, but it was inhibiting or it might have been 1/2, I don't wanna say for sure, but definitely her pathway in ovarian cancer cells.
It was inhibiting that. Okay.
I do believe that's what it said.
Depends on the cells.
Yeah, that's interesting, right? Because damaging agents activate ERK1 and ERK2, right? So if you're, sometimes growth factors do too, but so does stress.
Right.
And so if you're dampening that stress through antioxidant effects, then you might be reducing the activation of the MAP kinases as a secondary effect of dampening the stressor. Whatever that is, that could be could be oxidative stress, stress in the mitochondria, etc., which I think is worth looking at and thinking about the antioxidant effects of resveratrol. Because isn't it known to be like high? Because plants have to prevent ultraviolet radiation mediated oxidative stress.
I guess,
It has resveratrol.
yes, it has to be something, you know,
Sounds Japanese.
I think you can't find it in America. I don't.
Cannot find it in America.
It sounds, any of you know what it is, or?
It's Japanese.
Japanese,
okay, that makes sense.
Yeah. Yeah, I can't say I've tried that. I've tried about every other tea though. I haven't tried this. But yeah.
You can get it in Amazon.
There you
Get
go.
everything out.
Well, then I'll order some. I'll order some for the group then.
There you go.
I'll order some.
It's made from Japanese knotweed.
Not to weed, okay.
That's very cool.
Wait,
We get some of that in the lab.
Sure.
that's fine.
Actually, Dr. Wanderby did a tea study, what was the tea, I forget.
Oh, I don't know.
Does anyone from her lab remember? Tulsi, oh, the Tulsi tea? Yeah, yes, yeah. She also did something else when Bill was here a long time ago.
Yeah, that was with Vicky, I think, that was
what?
with Vicky.
With Vicky, yeah.
Yes, please.
So, do you have any idea about what kind of formulation is this? Like, is it oil in water, water in oil emulsion?
The art recipe question.
And whether resveratrol is in the water phase or in the oil phase, because that would make sense, because you're targeting surface receptors. PD-1 is a surface receptor. What if the oil is not allowing resveratrol to come out of the oil phase, if it is in oil phase, and it goes directly into the cytoplasm by crossing the lipid bilayer,
Right.
and it is in fact not affecting the PD-1 but affecting ERK inside.
Right.
And
Yeah.
so in that case you may not get the response that you were looking at. Like if it,
That's a good
of course
question.
you may get the response by like interacting with the ERK5 and not with the PD-1. Like
Okay.
you're targeting like downstream of PD-1 maybe.
Yeah.
Another thing is, what was the surfactant that you used? Just like this more from formulation aspects, because I think surfactants may cause damage to your surfactants may cause damage to the TNBC cells directly. And what if you change the surfactant to a milder surfactant, and your resveratrol is not interacting with your surfactant? What if the surfactant is basically interacting with resveratrol and not allowing it to move out of the emulsion system and reach the PD-1?
Yeah, that's a good point. It's a good question. I think that
These are all formulation related stuff.
right, speaking in terms of the formulation, this article that I mentioned here has everything regarding formulation that, I'm being honest, I don't remember that I could speak to it. I mean, I want to say it was oil and water, but then again, I have to look into this. Can't say for sure. I have to look into this article by Michelle Hernesti. She was here a few years back. But you mentioned great points with the specifics of it. I mean, when you look at what was used in Dr. Yange's lab, you're right when you speak to how unique the triple negative breast cancer cells are. So I think when you mentioned that how the role that surfactants play in there, it's just, it could be different from what they saw in Dr. J's lab, which is why it may throw some of the data off and may show us something that we don't expect. So that's something I'll look into. I'll get back to you on that too, about the formulation, and then from that look to curbing expectations or.
Because I'm concerned, like, though resveratrol is maybe efficacious, but then it's not able to come out of the oil phase. Like if it is in the oil phase, it's not able to come out of the oil phase.
Exactly.
And another thing is, you're also giving free resveratrol, right?
Yes.
And you said resveratrol is chemically unstable. Like it has some
Yeah.
instabilities.
By
Then
itself.
how are you giving it like free form of resveratrol to the as a control in your
I
experiment?
think that we do it expecting that it won't have, I guess, good effects, but just for a control. So in terms of like the actual procedure of it, I believe that we did calculations for that, and then we had free resveratrol, and it was a precipitate that was kind of like a white powder.
He's not asking about the calculations, he's asking about how did you add the resveratrol.
Like Was it
Oh,
like
we had it-
water-based delivery?
Yeah,
to,
it was via,
oil-based?
we did pipette, we pipetted that in and
Dissolved in DMS.
and it was dissolved, okay,
So it's organic.
yeah.
So I'm assuming the emulsion is then oil in water because you use DMSO for free resveratrol, which is organic, and you wanted resveratrol to be soluble in oil first and then make the emulsion.
Right.
So it's oil
That'd be
in
a
water.
safe assumption.
Yeah, and resveratrol is actually hydrophobic, so
Right.
it will tend to be in the oil phase.
Correct, makes sense. So I'm worried like the resveratrol is not leaving the oil system when you deliver it, and it's going straight into the cell.
Are you saying that's because of the nature of the triple negative breast cancer cells? Because in the, is that what you're saying? Because in the macrophages, like, I believe that it would leave. I believe that in the other lab, it has shown that it would leave, it kind of reduces its desired action. But you're saying maybe with what's expressed in the cell, different proteins,
Okay.
maybe it's not. So, again, maybe that.
What he's saying is that the resveratrol is not targeting the PD-L1 receptors.
Right.
Maybe it's bypassing that and going straight into the cytoplasm and
Downstream.
working on ERK or something like that.
I think so. It's happening.
Okay, that would make sense. That's something I'd like to look into more too. Yeah. Sorry, I can't speak to the certainty of if that's happening though. Thank you though. Appreciate it.
You wanna take a break now and come back in a few minutes, or you have to go to class? It's 1:08, 1:06.
I mean, eventually. I mean, it's
Oh, okay. Which class is it?
what's it called?
This is, today is not very important.
It's not very.
Okay,
It's not.
okay.
I'm not too worried about it.
All right, that sounds good. Cause we'd like to continue asking you questions and bothering you. If
I'd
you
love
have
to
some
answer.
time, you can stick around. We usually take a break around this time.
Okay.
You know, just 3 minutes, 4 minutes, something like that. Then we come back and we dive in a little bit deeper,
Okay.
into the data. Jane's welcome to stay if you have time, Jane. It's up to you. But that's usually what we do. We just stretch a little bit, give the speaker a break. Yeah.
Yeah, I could do either. I could come back after the class, or I mean, it's.
Oh, after the class.
recorded,
Oh, so you do need to go to class.
No, we don't. I mean,
Should go to class.
Who's teaching?
Neptune.
Dr. Locks.
Dr. Locks.
Oh, Dr. Lott.
Yeah.
It'll be all right.
Yeah.
Okay.
I'll tell him, can't come. I don't know. I have to go.
You want to go? I mean, the other option is that we don't have the break, and we just
Mhm.
continue
What
asking
time's your class?
questions, and then you leave in a few minutes. You wanna do that instead? I think we
Yeah, I
should.
mean, I'll field a couple more questions.
Yeah.
I'll hang out with
Yeah.
guys. Love to.
Maybe resveratrol really kind of protects the membrane in a way that, because like if you think about, if it's a lipid, it's gonna go into the membranes of the cells,
Right.
right? And then that could, to some degree, cause a little bit of destruction of the membrane because you're separating out what's naturally there, you know? And it doesn't have the proteins to hold it all together. And so just adding fat into a culture is going to have some degree of breaking open the membranes and causing some sort of necrotic response, right? And so resveratrol may have sort of unique understudied roles in preventing, in protecting membrane integrity that might be, or increasing ATP. There's lots of ways to explain the data. But related to that, I had a question about how it was checked that the nanoemulsions were not toxic in the raw macrophages.
Right.
Because those are cells that are designed to be phagocytic. They're going to engulf the lipid particles, and that's their job, is to remove garbage, right? And so, you know, if they are studied as far as their reactivity, that's one thing. That's one way to understand how it's activating immune cells because
Right.
there's some toxicity. Or if it was just through a cell titer-glow assay to see if the macrophages reduce in numbers and have, you know, proportionately less ATP present, then that's, I mean, they probably looked at it in multiple ways. I'm sure they've looked at many ways of the nanoemulsions and determined that the true because for multiple reasons. The assumption of this test is that every cell produces the same amount of ATP, which is we know not true, right? Like
Yeah.
resveratrol may increase ATP per cell, the nanoemulsions may activate ATP mitochondrial activity in the macrophages so that they have more energy to engulf what's in their environment that they see as dangerous. You know, so there's lots of other things to do, including just doing regular old cell counts, you know, looking at macrophage reactivity as an output, like our cytokines released. Are the macrophages activated by the resveratrol, by the nanoemulsions and by the resveratrol? And are regular cells, like post-mitotic neurons or something like that, also not activated by nanoemulsions because they're never toxic? You know what I mean? Like there's lots of things to kind of, lots of questions to ask.
Yeah, there's definitely a lot there. You mentioned a good point looking at, when you look at the cell tox data with the macrophage. I know Dr. Cotton and I talked about, you know, do we have to bring, like, should we include macrophage cells with this to phagocytose, like you mentioned, or something along those lines. So,
I think Sherlock did cell titer flow assays with the macrophages as well. And
right, and then that showed,
no
I mean, that's to
toxic-
ensure that the cells live, the macrophages.
Right, it's to ensure that the nanoemulsion is not toxic on its own. And that's why they're very surprised by this data. Because they,
Wow.
I guess in all the cells they've tested, which I don't know the list of all the cells they've tested in Dr. Yanich's lab, but they've never seen toxicity of the nanoemulsion alone.
It could just be the batch, this batch.
It could be something we did. I mean, this is the first time we're
Yeah.
using these nanoemulsions with cell titer flow. Who knows? I don't. So we're gonna have Sherlock. The idea is that Sherlock is going to do what we did with our cancer cells and see what he gets. Just because
Yeah,
it's done it
that's a
so
good
many
way.
times. Yeah.
Yeah, I spoke with Dr. O'Donnell briefly before this, and just because she couldn't make it, and so like, she kind of rose like the point of how unique the cancer cells are. Could it be something about MDA, MB like 231,
Yeah.
why it's,
They have a high level PDL1 expression.
okay.
They do, yeah, they do. So for that experiment, they'll be fine, but yeah, it could, yeah, I mean, they're messed up cells, right? They're really, it could be something. That's why we talked about using different triple negative breast cancer cell lines as
Different
well,
types, yeah.
with different genetic, profiles to see, cause that could bring up something very interesting.
Yeah.
If there's something specific to 231 cells that is not in other triple negative breast cancer cells, that could be interesting as well.
Like speaking to the aggressiveness of the
I think
cells.
also the genetic profile, they have different mutations. Triple negative breast cancer cells are not all the same. Like, they're the same in regard that they don't have high levels of any of the receptors, but they're different in terms of what mutations they have in different pathways.
Okay.
Yeah, so.
Yeah, that's something that would be good to look at.
Mhm. Yes.
I appreciate Asif for making time.
So maybe, so if you go to your hypothesis for AIM2, yeah, so instead of the sub-hypothesis inhibit the interaction of PD-1 on the T cell and PDL on the cancer cell, we can't really tell that with our cultures currently, right?
Right.
Because we don't have the co-cultures. So we'd have to do co-cultures for that. So I guess the better sub-hypothesis would be that it inhibits the downstream signaling from PDL in the cancer cell. Unless we're going, and we could try co-cultures, but Dr. O'Donnell mentioned that could be expensive for some reason, I'm not sure why. Yeah.
Because of the inserts that you use.
Oh, the inserts, right, yeah.
But you can just put the cells together too. You
couldn't you just put them together?
Yeah.
And you can't say, you can't do sulfide glow because then it's too sulfide.
Oh, right,
You
sure.
know, you'd have to do immunostaining to distinguish.
Yeah, yes, yeah, right. So just a thought there, we should be, I didn't even think of that when we were working on this. Yeah, we can't test the interactions with our current model, but we can test the downstream signal.
Of, like PDL1, right? Okay, that's something I'll definitely,
Yeah.
thanks for bringing that up. I could, cause I believe in that, that'll show cool data, I believe. We can even look into that.
Yeah,
That's a
we'll
good
look into
point.
how that can be done, if we decide, so reading more of the literature, if we decide that the interaction is really what we wanna look at, then we'll have to do the cold cultures.
Yeah.
Even if we do it the cheap way.
Just trying to look up sirtuin because I just remember reading that resveratrol activates sirtuin.
Does.
And like I'm trying to understand what they do to their histone release function and how that might explain some of your data.
I don't even know the
Might be
expression of sirtuins in these cancers, so.
They're not?
I don't know,
Oh,
but that's a good question.
I think, look at my Western blot. Excuse me.
Western blot after, so I mean, we'd probably do a little more experiments before getting into, for that anyways, right? I mean,
Yeah.
ideally
Yeah, we would start with ERC5, honestly, just cause we're so
familiar with it.
familiar with that, and then
That makes
in the background, we'd be working on the PDL stuff.
Yeah, that would make sense, especially after learning about the interactions, how that's kind of not really
Right.
realistic. I mean, I think that maybe shifting the focus to ERC5.
Well, just for now, and we can
For
always
now.
think about the PDL, PD1 interaction a little bit more.
Yeah. Yeah, thanks for bringing that up.
Yeah, I think, any other student questions?
Okay, like you mentioned the increase in number of like in the rows EFG,
Say that again?
could you go back to what you mentioned about the rows EFG, why there's more, why we may see more cells there? Do you think that could speak to the mechanism of resveratrol, or is that just a side note that you mentioned earlier?
Rows, which rows, 2 and 7?
EFG.
EFG.
Rose
Oh,
EFG.
EFG. I didn't say much about EFG. I think Jane said some stuff about EFG.
Okay.
EFG is just across the columns, you're increasing the concentration of free resveratrol, and it's, as far as I can read, not having much of an effect, right? A little
Okay.
bit reduction.
Yeah.
High, very high.
Maybe, yeah, but just to be expected.
Yeah.
So, be interesting to see if free resveratrol combined with the nanoemulsions prevents the nanoemulsion
Yeah.
mediated loss of ATP or,
Right.
you know,
Thank you.
I mean, that looks kind of real to me because it's like twice and it's tight
You
here.
can also
when you're
maybe
not
add
there.
hydrogen peroxide to the cells for both the drug-free and drug-loaded nanoemulsions and see if
Could try something like that. That's
For what?
certainly-
so like if we use hydrogen peroxide, that's like causing oxidative stress. So
Oh,
then
yeah.
if, like the resveratrol in the nanoemulsion is doing something like that, then
Yes, yeah.
That's a good point.
Just remember, keep in the back of your head, in your back pocket, that the ATP levels can go up without a change in cell number.
Yeah.
We always assume it's in proportion to cell number, but it's not always.
Okay, thank you.
Again, every assay has its limitations, as Dr. Videnter was saying.
Definitely keep that in mind also going forward.
Yeah.
Can't make that assumption.
It's a very sensitive assay, but it has to measure something, it measures ATP. If you could divide that ATP levels by how many cells you have on a parallel plate, then you could have ATP per cell.
Okay.
It's a bit indirect, like it's a different plate, so it's not great, but I don't know what else to do.
Yeah, well,
Because once you destroy the cell, you can't do immunostaining on it, you know, the sulfide glow has, detergents in it trying to break open the cell membrane.
Yeah. There's definitely a lot of ways to look at
unsaltated glow on it, the middle wells have more ATP than the side wells because of the edge effect. So it's like a real U-shaped curve. Yeah. That's something to also try. I think that would help a little bit with the variation.
Yeah, sterile water in all the wells around the outside would be good.
Yeah, I remember Sherlock describing it kind of like a moat, as when at least when he did it, keeping those, like the perimeter kind of empty, but I'm not really sure.
Well, I think it would be, I think the reason for that is to lessen the edge effect, cause the more
Yeah.
you go into the center of the plate, the better, but if you do
Yeah,
put a little bit of water, well, then I worry though a little bit about moisture, like,
It's not a problem, there's so
No.
much moisture in the incubator.
Yeah,
you
yeah.
know, but
Okay.
what does happen, and I don't know that we all know really completely the reasons for it, but the 96 well plates have that problem, that the middle rows and the middle columns, the center of the plate has the best viability value, always.
there's some evaporation, some loss.
There is still some evaporation when you take the plate out of the incubators. The incubators really humid, but when you take the plate out and treating it and just leaving it, you know, with the lid on, the
Even
middle of
leaving it
the
in the
middle
incubator
is,
For a while, even leaving it in the incubator for a
Yeah.
while.
yeah,
I mean, the humidity's not enough to save it completely.
yeah, the fluctuations in temperature are gonna be less in the middle of the plate than
Right.
the edges of the
Yeah.
plate. So there's many reasons that the edges could have some lower viability, you know,
Yeah,
than the sides of, than the middle of the plate.
yes.
Yeah, I think we're okay.
All right.
You're all right, right?
I'm just tired.
Yeah.
I appreciate you all coming today.
Yeah, thank you,
Okay,
Celia.
yeah, thank you, Celia.
Our sincere apologies about the slow start to the academic sense.
You know, it's brave to go in front of graduate students and professors and describe your research that you've done for 2 weeks.
It is.
Right, so
Yeah.
that's all very good.
Yes.
I appreciate